You have looked at Jupiter your entire life without knowing it. On any clear night, it is one of the brightest things in the sky. It doesn't flicker the way stars do. It just sits there, bright, still. You've seen it hundreds of times and called it a star and moved on. Jupiter is so large that every other planet in the solar system combined would fit inside it with room to spare. The Sun is the only thing larger. In 1989, we launched a probe toward Jupiter. 6 years later, in 1995, we dropped it in. It was never coming back. We knew that. We built it to go as deep as it could before Jupiter took it. It lasted 58 minutes. This is what it found. Let's begin. From here, it looks small, a point of light, one among thousands. It isn't small. Take every other planet in the solar system: Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune. Gather them into a single impossible world. Lower it into Jupiter, and there would still be space left around it. That's what we dropped something into. Jupiter has no surface, no ground to stand on, no boundary between atmosphere and interior. Just layers. Gas becoming denser, pressure increasing, temperature rising, depth without end. We built a probe, the Galileo probe, about the size of a person, a carbon phenolic heat shield, making up nearly half its mass, titanium pressure vessel, instruments inside to measure temperature, pressure, composition, wind speed, a transmitter to send the data back, batteries to power it for as long as possible. And we dropped it in. On December 7th, 1995, the probe entered Jupiter's atmosphere at 106,000 miles per hour, fast enough to cross the continental United States in under 2 minutes. The heat shield glowed white. The deceleration was brutal, well over 200 G, enough to crush a human body instantly. The probe survived. And then it began to fall. The parachute deploys. The heat shield drops away. Descent begins. It doesn't fall freely. It drifts, pulled down by gravity, slowed by the thickening atmosphere. The sky above is bright, sunlight filtering through the upper clouds. The atmosphere here is cold, almost Earth-like in pressure. But it's already changing. Deeper now. The light begins to die. The clouds thicken. The sun becomes diffuse. A glow, then a hint, then nothing. The darkness is absolute. The temperature rises, and not from sunlight. There is no sunlight anymore. From pressure. The weight of the atmosphere above pressing down, compressing the gas, turning pressure into heat. The probe is 15 kilometers down, then 30, then 50. The wind begins. Not wind like on Earth. Wind with no solid surface to slow it. No mountains, no land, just flow. Jupiter's atmosphere moves in vast, unbroken bands, jet streams hundreds of miles wide, circling the entire planet continuously. The most violent hurricanes on Earth can reach speeds of up to 200 miles per hour. Jupiter's jet streams move at 300, some faster, and they never stop. There is no season where they calm, no part of the planet where they don't exist. The probe is inside one now, shaking, transmitting. A storm on Jupiter is not an event. It is the condition. Deeper still, the temperature climbs past 100 degrees, past 200. The pressure builds, 5 times Earth's atmosphere, 10 times, 20 times. And here, something happens that has no equivalent anywhere you have lived. In ordinary experience, gas and liquid feel completely different. One you breathe, one you swim through. The boundary between them is something you can feel, cross, stand at. Here, Jupiter's gravity erases that boundary. The atmosphere is too compressed to behave like gas, too hot to settle cleanly into liquid. It becomes something that fills every space available to it, dense, pressing in from every direction. No surface to push against, no boundary to cross, no floor coming to meet you. The probe is no longer falling through air in any sense you would recognize. It is sinking. At roughly 23 times Earth's atmospheric pressure, 180 kilometers below where it entered, the transmitter fell silent. There was no crash. The heat and pressure simply exceeded what anything we built could survive. The probe reached its limit and stopped being a probe, and kept going, past the depth it could measure, past the depth it could transmit, into the layers below, layers it never reached, never saw, never touched, sinking into a darkness that had never once been interrupted by light. And somewhere far below, thousands of miles below, something was waiting that no probe has ever come close to. Far below where Galileo fell silent, in Jupiter's deep interior, something else exists. At a certain depth, thousands of kilometers down, far beyond where any probe could survive, hydrogen stops being hydrogen. Not chemically, it's still hydrogen atoms, but the pressure becomes so immense that the atoms are crushed together. The electrons are stripped away, freed. They move independently, conducting electricity. Hydrogen becomes a metal. Think about what that means. The most abundant element in the universe, the simplest thing that exists, crushed past the point where its own rules apply. Hydrogen is everywhere, in stars, in the space between stars, in your body. You are partly made of it. And deep inside Jupiter, it becomes something that conducts electricity, something that flows like water, but carries current, like copper wire. Something that has no equivalent anywhere you have ever been or will ever go. This is not a metaphor. It is liquid metallic hydrogen, an ocean of it, beginning perhaps halfway to Jupiter's center, extending for thousands of miles. We've never been there. We've never even come close. But we know it's there. Everything we know about it comes from the outside, from mathematics, from the way Jupiter's gravity behaves, from the magnetic field that bleeds out millions of miles into space and tells us something enormous is moving down there. We've never sent anything close to it. The Galileo probe, the only instrument that ever entered Jupiter, reached 23 atmospheres before it stopped. The metallic ocean begins far beyond Galileo's last measurement, and deeper down, the pressures rise into the millions of Earth atmospheres. Between where Galileo fell silent and where the ocean begins is a distance we have never crossed and have no way to cross. We know it's there the way you might know a room exists behind a wall you cannot open, by what leaks through. Because Jupiter has a magnetic field, the strongest planetary magnetic field in the solar system. And magnetic fields require motion, electrically conductive material, moving, circulating. Deep inside Jupiter, the metallic hydrogen ocean is in constant motion. Imagine what it would be like down there. If you could somehow survive the pressure, millions of times greater than Earth's atmosphere, if you could somehow survive the temperature, perhaps tens of thousands of degrees, you would be suspended in liquid metal, neither floating nor sinking, just held by pressure so extreme it defies comprehension, in darkness so complete it has no name in any language built for the world you come from. The ocean would be flowing around you, thicker than water, more viscous, moving in currents driven by the planet's rotation. And you would feel the motion, the circulation, the metallic hydrogen rising from the depths, cooling, sinking back down, creating eddies, currents. This ocean is older than Earth, older than the moon, older than anything on the surface of our world. It has been there since the solar system was young, since before Earth was solid, since before the first life appeared in our oceans. It was moving when no one existed to look up and wonder what it was. And it's moving now. Right now, in this moment, thousands of miles below the clouds, circulating, conducting, generating a magnetic field that reaches farther than the distance from the Earth to the moon, a field that pulses, that shifts, that responds to the solar wind blowing past Jupiter, evidence of motion in the deepest darkness. Galileo never reached it, never came close. But the ocean is there. It has always been there, turning in the dark, thousands of miles below where Galileo fell silent. The Galileo probe transmitted data for 58 minutes. 58 minutes of temperature readings, pressure measurements, wind speeds, composition, the descent through the upper atmosphere, the hotspot, the unexpected conditions, all of it sent back as radio signals, crossing 400 million miles, from Jupiter to Earth, to a room at NASA's Ames Research Center, where scientists were listening. And what the probe found surprised them. The winds were far stronger than expected, measurements indicating speeds as high as roughly half a mile per second, jet streams that dwarf any hurricane on Earth. The entry site was unusually dry. Scientists had expected to find water-rich clouds, layers of ammonia and water vapor trapped in Jupiter's atmosphere. But the probe descended into a hotspot, an anomalously dry region. Less lightning than predicted, less water than models suggested. It may have been cosmic coincidence, descending into one of Jupiter's driest regions, or it revealed something about how Jupiter's atmosphere circulates that we didn't understand. The temperature was rising faster than expected. The greenhouse effect, heat trapped from below, was stronger than models showed. Jupiter's interior is hotter than we thought, more active. All of this in 58 minutes. 58 minutes of data from the upper atmosphere of a world we'd only seen from the outside. And then the signal stopped. The transmitter went silent, and the remains, whatever was left, kept sinking. Deeper into Jupiter, past the depth it could measure, into the layers it never reached. Eventually, those remains were crushed, melted, and vaporized in the deeper atmosphere. The carbon, the titanium, the instruments, everything, broken down by pressure and heat and time, dispersed. The probe became part of Jupiter. There is no marker, no trace, no way to point to a place in Jupiter and say, that's where it ended. The atmosphere absorbed it. 30 years later, it's gone. What remains are the 58 minutes. The data, the measurements, the discoveries that surprised us. The glimpse of something we had no right to see. 30 years from now, the ocean will still be there, moving, conducting. 300 years from now, 3,000. In a billion years, when Earth's oceans have boiled away and the sun has grown hot enough to sterilize our world, Jupiter's deep ocean will still be turning in the dark. In 5 billion years, when the sun swells into a red giant and the inner planets are gone, it will still be there. And in all that time, across epochs we can't comprehend, through the end of our world, whatever remains of the probe will be there too, lost somewhere inside Jupiter. We got 58 minutes. Jupiter got the rest. And the ocean will never know we were there.